Scott and I wanted to take a few moments to discuss the New England Research Cloud. My name is Gilmore. I'm the Executive Director for Research Computing here at Boston University. And Scott Yockel is the Head of Research Computing at Harvard University. So when Scott and I first started discussing this back in 2018, I think it was 2018, we both had a need to be able to deal with the emerging workloads of the research community that typically don't fit in the high-performance computing space. So we were discussing whether we could build upon the successes of the Mass Open Cloud Alliance and the relationships with the Red Hat Collaboratory to build a production cloud environment to service not only our researchers within the two universities, but also researchers at institutions regionally in incubation hubs for small businesses in the Massachusetts region. So the vision of NERC was born, and really we were looking to do a few things. Build cost-effective production cloud resources, standardize the deployment so that it could be reproduced by other centers, facilitation with clients for effective use of the cloud. So we both have very strong facilitation efforts in our research computing groups, and we build upon that to actually facilitate researchers to use the cloud effectively. And then finally, can we take all of that usage from the production cloud environment and feed that telemetry back to systems engineering researchers so that they can do innovative research with that data. So this is where NERC fits in within the ecosystem, and like John was mentioning a couple talks ago, we have the MGHPCC. I'll try to hold the microphone a little further away. This is the ecosystem for NERC, and you can see that as John was talking about, the MGHPCC is on the bottom here, and we have the Northeast Storage Exchange, both very successful projects that NERC heavily leverages. And then one of the unique aspects of what we're doing with NERC is that we're able to take innovations that come out of the MOC Alliance and really leverage the development team, so much which Scott will talk about in a little bit, and actually develop new technologies and be able to provide that within the production environment for researchers to be able to leverage. And then finally, can we make the communities, the research communities and the education workforce community actually leverage the production cloud in an easy to use way? So can we have an easy access portal? Can they actually use their institutional credentials to actually access the service? And can we pair that with cloud facilitators to be able to help them get their workload running on the cloud? And currently, for NERC, we have the following three core services. So the first one, which is virtual machines, and that is in production right now. We have 50 investigators, over 65 projects from 7 institutions that are currently using this service. And because of this, the Mass Open Cloud Alliance has been able to shift all of their workloads onto the production cloud, freeing up a lot of their efforts to be able to work on development activities to enrich the production cloud and help it move forward. And then the second service is container orchestration, and Mass Open Cloud with assistance from Red Hat through the Collaboratory have been able to develop OpenShift service, and we just had that handed over to production. And we'll be opening that up for onboarding on April 1st. But if there's any test users in this audience that would like to try this sooner, please do reach out to either Scott or myself, and we can help you get onboarded now. And then finally, we're looking to pin up software as a service on top of that. So one of the first projects that we're working on is the Red Hat OpenShift data service, which is currently in development, and that'll provide a platform for AI researchers to be able to do their analysis. And now Scott's going to talk about some of the supporting services.
Thanks, Wayne. So one of the challenging parts, every time we stand up a technical service, is there's all this other apparatus, what we call business ops, that has to go with it. So you have to think of every service for a researcher in some domain like chemistry or physics comes in, we're normally not completely using in the research space all of the different standard services that are part of enterprise IT in a lot of our institutions. So that means identity management, resource management, how do we give allocations of resources to faculty, how do they decide how much to have for each user, manage users, how do we support users with ticketing, with documentation, how do users know how the equipment is operating, how the servers are operating, right, with dashboards and things like that. So as in the MGHPCC, as we transition away from doing purely institutional services just for our researchers and think of this collaborative space of shared services, we don't want to have to build that infrastructure that I just described every single time. Because building out that infrastructure, for the most part, takes more time than actually building out OpenStack or OpenShift. So I'm going to walk through a few of what we've deployed, and how we deploy these is not meant just for NERC. These are available across the MGHPCC consortium. So one of the first parts was identity management. So thankfully, within MGHPCC, we have a resident expert. I don't know if Jim would say that, but we feel that way when we engage with Jim about identity management. And thus far, we've installed a web front end that on the back end. So the user experience is they come to the education application, they register their local credentials, right, with this on the back end. Keycloak is storing and matching these to a local user. That local user then can be used across any service, right? So that's nice. So on the front end, it's in common, which most of the institutions in higher ed are a part of. So that makes that nice and easy. So anybody can come and authenticate and log in across the consortium. When they do that, then a PI can go to Coldfront. So Coldfront's an application that's an NSF-funded project after University of Buffalo that we partnered with. It's a simple portal that allows you to say, I'm a user, we can upgrade you to a manager, and they can manage a project. In a project, they can add allocations of resources. So any resource can be defined, and they can also define users. Users are looked up from Keycloak because they've registered already. Once they do that in Coldfront, it's just a Django app. On the back end, you can push data to any system. So the OpenStack, OpenShift, all those systems get a feed of what is a project, who has access to the project, what are the quotas. All of that can be managed simply from the research room. We don't have to have tickets, all this back and forth. They can see what their consumption is. So a couple of the other aspects are having documentation. So we're just using something pretty straightforward. We're just using GitHub.io. So we generate docs that anybody can push to. They can be on a website. It's easy for everybody to have access to them. And so we can contribute multiple ways to that documentation. So when you go to use commercial cloud, you don't necessarily have the kind of tailored like cookbooks or workbooks of the types of things that you want to do. In the research computing communities within our institutions, there's a lot of like kind of rinse and repeat infrastructure for what people are building. There's a lot of what we call science gateways, right? A science gateway with a web front end, some compute engine on the back end. There's always some database that keeps information and provides a visual representation of your research, right? It makes it easy to do a wide breadth of kinds of research, especially far outside of the space of traditional STEM, which use high-performance computing. So we can provide rinse and repeat of these kinds of environments and cookbooks for them. The other aspect is a ticketing system. So luckily we convinced Goodhue, hey, maybe we should all collaborate and use the same ticketing system. So we went after OS Ticket and do a hosted service. We're going to have to manage our own ticketing system. But the nice part is, because we're doing it collaboratively, all the different projects we need to see, and interact with each other across multiple projects. We can do that within the same system. And we also use InStatus as a way to demonstrate to the user community what is the uptime of various different services. Every time we put in a scheduled maintenance, it automatically emails. So it makes everything systematic across all the different services so the users have the same experience. The other aspect is reporting. And so in high performance computing, a lot of the NSF funded seed sites, like the tier 1 and tier 2 sites, I've leveraged this application. A number of years ago, they extended it for OpenStack. However, as we found, not as mature for a modern OpenStack deployment. department, so we've done a lot of work with them and have made some updates, and we also figured out a clever way to also use data from OpenShift to put into XEMod. But XEMod is nice in the sense that it's built for university style. It has a hierarchy of institutions, science, discipline, a project, a PI, users. So you can roll up this hierarchy and create nice reports from it. It has a portal that then users can log into, faculty can log into and see how their utilization is. So that's what we're using for reporting and keeping track of the accounting mechanisms that would be across multiple different services into one single portal. So one of the other services, just we talked about a few times, is the Northeast Storage Exchange. This is managed at Harvard University by storage engineer Juan Gipsey. And there's two basic services at the top. There's NESI set, disk, NESI tape, provides tape. And so we really thought about who are the customers of NESI. And the customers of NESI are not end users. The customers are these other projects, right? So the what we call the data manager or the storage manager at the other institutions, right? And so we provide some basic services that the whole point was to abstract ID management away from handing out storage. So we do this a lot of times through using Globus. So we provide file access to data transfer nodes via either StepFS, or if we do it on the tape side, we're doing it via spectrum scale. And we can hand off a chunk of storage that media is owned by the institution. They decide, how do I want to chunk it up? And they can log into Globus, right? And all of the federated identities of the Globus users from their institution can be managed through the portal, and on the back end, it's just one system user for that institution. It's a really nice abstraction. It also gives delegated administrative access. Globus is also nice because you can create user-based authentication for, all the way down to, a file or a collection, and you can do it for durations of time. You can have it be private, you can have it be public. You have a lot of flexibility as opposed to if you were just doing an S3 bucket and you're handing out a read or a write, right? You can't expire that. You have to build that token, give everyone new tokens. So it has some interesting flexibility in that space. So that's why we went down that path. And it's kind of that kind of cloud storage space that's kind of in the middle. It's not active on the high performance computing space. It's not active on other things. It's kind of an intermediary space to store things. When you think about it on a disk, on the tape, it's kind of a long-term cheap storage. Inside the data center, though, we can hand out across the high-speed network. We can hand out RPDs. Every institution can decide what to do with it. They want to mount it up with a block device, serve it out via NFS to their cluster, attach it to a VM store. They can do whatever they want to with it. And as you heard before, Northeast, so the new research cloud, so in NERC, we use it across back-end our data store. I'm switching to give you just a couple of highlights. So it's been really interesting to watch. It's an experiment. Neither one of us have run the cloud. We've not offered that as a service to our users. At Harvard and in Faculty of Arts and Sciences research computing, in those days, we did a lot with VMs and hand those out. So we had some idea about how people might start to use this. But it's really been interesting to watch like faculty from history, political science come in and build out an entire data structure, right? And realizing that using a standard database is not going to work for what will be 100 million articles that they want to put in this data store. Right? So they had a conversation with Milson. Milson was like, hey, there's Elastic, let's think about that. They built that out, some indexing on it, and they're able to search and do all sorts of interesting looks at partisan bias across historical number of years, right? Those are the kinds of research questions that would be really challenging to ask if you didn't have resources and people to help you think about the way to do that, right? Most graduate students in history are not thinking about the infrastructure that's needed to put 100 million articles together. That's one of the things that's interesting. Earth and Planetary Science, Professor John Shaw, using, needs lots of different Windows instances in order to do the simulation, in order to have graphical understanding of the predictability of earthquakes. We see all sorts of, the next one here by Professor Xiang Lin in public health. It's a really typical type of thing that we see in public health where they want to develop a portal that their research community would come and use. And on the back end, they're developing various different algorithms to be used, launched as part of the computational side of it, but it's also tied to a large database, and on the front end, it's like a community portal, right? So this is one for whole genome sequencing studies that they use within there. So Wayne's going to give a few more highlights before we finish up.
Great, thanks, Scott. So on the BU side, I just wanted to reference 3 projects, and there'll be more projects I'll be referenced this afternoon's work lot. The first one here is from School of Public Health in Kevin Lane, and he's really interested in providing analysis on accessibility of different services, parks, grocery stores, etc. And they first set this workload up on AWS. They were looking for a more cost-effective, better solution which to control. So we actually ported that workload over to the production lab, doing the research lab. And it's been very successful, and they're looking at actually leveraging that service for other research projects at the medical center campus. The second one here is a good example of a web gateway that needed to be created for a researcher, Stefano Monti, to help identify candidate drivers for cancer. And so my group through Research Computing, we helped actually develop largely the workflow, and then we were able to port that to run on the production clouds where outside users can access it and actually use the service. And then the third one here is really support of academics, and we actually supported our first academic course. Many thanks to Nelson that helped me actually set up all of the accounts and applications for this. But this was for computer science class and the user-centric systems and data science. And we actually onboarded over 50 students who had about 26 projects that they had to do as part of the coursework. And that was a very successful endeavor. Faculty members would like to use the service again for next time he teaches the class. And then finally, just some related events for production clouds. So there's Monday afternoon microtalks, and so that'll be 4:05. Ilse will be highlighting some of the work that has been run on the research cloud. And then Nelson again will be providing a tutorial session on efficient access to the NERC computational infrastructure. So essentially providing a step-by-step guide for how you can get onboarded into the production cloud environment. And then finally, we'll have multiple posters that'll be during the poster session that you can take a look at as well. So Scott and I would like to thank you for your time.